Okay, so let's try another example problem. This is your number 2. First thing we got to do is move everything over to the other side. So that means just the 1 basically. So that becomes negative x squared plus 2x minus 1 equals 0. Now, let's do a quick run through of what we've got. My a is negative 1, which means the parabola is going to turn down. My b is positive 2. My c is negative 1. So let's go ahead and start step 2. To get my axis of symmetry, it's going to be the opposite of b, so that becomes negative 2 over 2 times negative 1. Well, negative 2 divided by negative 2, our axis of symmetry is 1. Now, that's just a coincidence. We got the same axis of symmetry on example 1. It's not a big deal. So take a minute, go ahead, and draw in your vertical axis of symmetry through x equals 1. Go ahead and do that real quick. And now we're going to find our vertex point. We're going to take this value of x, plug it in, and see what value we get. That will be our y. So that gives me negative. Now remember, this negative is on the outside. It's like an invisible 1 here. So it's going to be negative times 1 squared plus 2 times 1 minus 1. Well, this is 1 squared for sure, but since it's got a negative on the outside, I got to make it a negative 1 plus 2 minus 1. Well, negative 2 and then negative 1s, these two negative 1s, that equals 0. So my vertex is 1, 0. So on your vertical line, your dashed line, you're going to put that vertex right there. Okay? Right there. So, hope you got that, because you guys are going to have to do this work. There's no shortcut for it. You got to do this basic arithmetic to get your numbers. Now, we need a few more points. So take your XY table, and I'm going to do 0 for sure. I've already got 1, because that's what we just did here. So I'm going to do negative 1, positive 2, and negative 2 again. That's just what I want to do. You want to do larger numbers? Go for it. More negative numbers? Go for it. But try to have both, positive and negative. So let's see what happens. When x is 0, first term's gone, second term's gone, all you're left with is negative 1. There's your first point. Now, we got to do a little work. X is negative 1. Let's plug it in and see what we get. So that's a negative still on the outside. Square the negative 1 plus 2 times negative 1 minus 1. Got a lot of 1s, so don't get them mixed up. Negative 1 squared is positive 1, but you got to slap that negative sign on it. 2 times negative 1 is negative 2 minus 1. So negative 1, like I said, grab your calculator if you need to so you don't make any Carol's mistakes. Negative 1 minus 2 minus 1 gives you negative 4. So we're going to put that right there. There's your second point. Now let's see what happens when x equals 2. So that's going to be a negative still on the outside times 2 squared plus 2 times 2 minus 1. All right, 2 squared is 4, but since it's got a negative, you got to make it a negative 4. Then that's plus 4 minus 1. Well, the negative 4 and the plus 4 cancel out. So that leaves you with negative 1. Got one more to do. Negative 2. Slap that negative sign on the outside. Square the negative 2. Plus 2 times negative 2 minus 1. Negative 2 squared is positive 4, but you got to make it negative. 2 times negative 2 is negative 4 minus 1. Negative 4 minus 4 minus 1. I know, your calculator knows. I don't know if you know. It's negative 9. So there is your XY table. Take your time on this, folks. I'm not going to hold your hand and do it for you. Take your time and do the basic math to complete the table. Now we're ready to take these points and plot them. We know for sure that the parabola should be turned down, so that's what you should see here. First point, negative 1, negative 4. So it's going to go right there. Second point is 2, negative 1. Then my next point is negative 2, negative 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I go all the way down. And then I can take my vertex and go down to the left and go down to the right. Now again, the other day you'd be done. But wait, look at it. How many times does this parabola hit your x-axis? How many times does it hit it? Do you see that it only hits it once right here? So if it only hits it once, that means that there's one intercept, which means that your answer, this entire graph, this entire function, only has one solution. So that is what I should see amongst all the work that you have for this problem. I hope you're getting the hang of it. It takes some time, but this is definitely not hard. We'll do one more example together on the back, and then